Okay, welcome students. Morning. Morning, Sophie.
Morning.
Good morning, Hannah.
Morning.
Maggie. Good weekend all?
Yes.
Excellent. Okay. Alrighty. Now, today, great to see you all. Another science lesson. What we're going to do first, remember last week. What did we do last week? What did we talk about?
Liquid solids and gases.
Excellent, Maggie. Now, seeing as you're so keen, can you want to come up and draw on the board here what you can remember about the solids? Okay. Now we talked about the physical properties of the solids, didn't we?
Yeah.
Okay. So what do you remember about it, Maggie?
That they're tightly packed
Yes.
and they're bonded.
Okay. So you're drawing lines there, joining. What are the lines?
The bonds.
Excellent. Rightio. Well, that's great. That's great. Maggie remembers very well. And they're tightly packed together, aren't they?
Yeah.
Okay? Very tightly packed together. That's why solids are solids. Okay? They're very hard. Okay, Rebecca.
Yes.
Can you come up? You might show the class what you recall about liquids. Where's the pen, Maggie Jane? That's a good flask. What do you remember about liquids?
They're weaker.
Weaker bonds?
Yeah.
And what does that let them do?
They move around. They can move freely.
Okay. So they can take the shape of... Yeah,
Anything.
excellent. That's good.
Shape of the jug.
Yes, yes, that's great. So gases. Can I get a volunteer? Hannah.
Yes.
Excellent. So what is it about a gas that makes it different, Hannah?
They're more distant
More distant, more space between them?
and they squash.
They can squash.
Yes.
That's pretty important, okay? Okay? So can solids and liquids, can they squash?
No.
What's another word for squash?
Compress.
Compress. Excellent, excellent. Okay, so we spoke about the application of that last week. Why do you think we use gas in shock absorbers in your car? When you're hitting bumps, okay? Why do you think we use shock absorbers, air in our shock absorbers?
Because it absorbs.
Yeah, it
Compress.
compresses, excellent. What if we had liquid in there or a solid?
It couldn't compress.
Yeah, it'd be pretty hard ride, wouldn't it?
Yeah.
Yeah, it'd be a pretty bony sort of a ride. Okay, well that's good. We've got a great base for today's lesson. Now what we're going to be doing today is going to work out, and you'll know by the end of it, how that can change to that and to that. Okay, so what we're calling there, it's a changing states of matter. Okay, so how solids go to liquids and how a liquid can go to a gas, and how gas comes back to a liquid, and how a liquid then can come back to a solid. Okay. We're going to be using terms such as, you can write these are the key terms that we're going to be using today. Okay. Heat. Cooling. What's another? Heat. It's a type of energy. What sort of energy do you think heat is?
A hot one.
Physicists? What sort of heat do you think?
Thermal.
Excellent. Okay. So we're using thermal. So if we're cooling, will we taking away the thermal energy as well?
I think so.
Okay. Now, will we write this one down? Anyone know what this is?
Condensation.
Good work. Do you know what it is?
When it freezes the water.
Sort of. It is cooling it. We'll get on to that.
When it evaporates and cools it.
There's the next one. You're writing that one down?
Yeah.
Okay. So there's some key terms that we're going to be doing today. Okay. We'll also touch on... This will form part of... We're going to have a bit of a game, lad.
Nice.
Okay, steam and water vapour. And what's an example of a solid?
Milkshake.
What's solid water?
Ice.
Excellent. Liquid water is water. And what would water as a gas? Would anyone know what
Steam.
water? That's good, mate. How do we know that?
Kettle.
Excellent, excellent. Okay.
Hey, so what's the Bunsen burner?
Oh, I was hoping you'd ask that, Sophie. Okay, now we're going to do a little demonstration. Okay? What do you think? Just get in your pairs now and just discuss what you think might happen once we light the Bunsen burner. That's water. Okay, and we've got a balloon up here. Looks a bit crazy, doesn't it?
Still little.
But something might happen. Something mightn't happen. What I want you to do is just discuss it with yourselves. What you think might happen once we heat that Bunsen burner. When we said here, gas, the particles are far apart. Okay, so we heated it. So what happened? What do you think happened to the particles?
They evaporated.
I went further apart.
Further apart. Okay, and now,
Into gas.
they did, Maggie. Excellent. They did turn into gas. And now the Bunsen burner's off. It's come back. What's happened?
It went back to a liquid.
Yes, yes. So what happened to the particles, the gas particles that were going
They
crazy?
evaporated.
Condensation.
Yeah. They lost a bit of energy. If we took the heat away from them, if the heat made the particles go crazy, what would happen and expand?
They contract.
They contracted, exactly. So the gas particles contracted and now we're back to the original place. Okay, so how does this happen? How does this happen? Now, we've got an ice cube here. We can see this, it is starting to melt. Okay. We're now seeing a changing state of matter. Can anyone, similar to this, describe what's happening here?
Evaporation.
Not yet, maybe, not yet. What's the ice cube doing?
Expanding.
Mountain.
Melting, yes. And the particles, does anyone know what the particles might be doing in the ice structure to form?
They're turning from a solid to a liquid.
Yes, they are. Yes, they are. At a particle level. We know that the liquid, that the ice was strongly bonded, okay? We're looking at the water particles forming on the outside of this, okay? So it's the addition of the heat and thermal energy, which is breaking the bonds. It's breaking these bonds at Maggie. Okay, Maggie? Those bonds are now going. Okay? When those bonds go, okay, that'll come across to here. Can we see that? Okay, those bonds are broken. So that ice is turning into water. Okay, the same thing happened here. The water, the bonds of the water were broken by the heat and it formed the gas, which Sophie said. You know, the gas came up, okay? Alrighty, so do you think you've got a good idea of what happens at a particle level?
Yeah.
So it's the energy, okay? We're talking about thermal energy. Okay, what is happening to the ice cube?
It's melting.
Yes, because,
Of the thermal energy.
yes, causing the,
Evaporation to take place.
these are vibrating, okay? It's causing these to vibrate a lot harder and removing the bonds, okay? So if we're going to go back to that, so if water goes back to a solid, what would happen to these bonds if we just froze that?
Stay strong.
They would strengthen again, maybe, yes, and form ice again. That's excellent. That's excellent. Okay, now, reinforcing this. Okay, we've got a little game. So, I would like a volunteer. Okay, what we've got different states of matter. We've spoken about here before. We've got water, we've got ice. Okay, we've got steam, water vapour. Okay, we've got all these states of matter here. Now, I need a volunteer.
Yep.
Actually, we will get a volunteer. Hannah? Okay, can you come up and choose a state of matter? Maybe just get water. It's up to you. Okay. Maggie, can you come up, please? And grab another state of matter that isn't water. Steam. Maggie's picked steam. Okay, now what we've got here, we've got arrows. Okay? What would blue for cooling and red would be for
Heating.
heating. Heating, the addition of what sort of energy?
Thermal.
Thermal energy. Excellent, excellent. So, you can come up, we can go either way. Remember this is reversible, okay? So what I want you to do, Sophie, grab an arrow and tell me which way the heat or removal of heat goes. So what are you saying here? That steam,
Cools and goes to
water. Okay, and what is that phenomena called? We've got some terms here now. Okay, so if you wanted to come up here and get some two. So condensation. So that's one of our terms here. So when you come back to your tables, okay, you can write your own little definition of what you think condensation is because you've actually seen it. Okay, it's the steam taking away the heat energy or cooling is now the water. Okay, thank you. Okay, we'll put them back. Now coming into winter, Rebecca, can you come up? What happens at night, early in the morning, the grass? What happens to the grass? Excellent. So, Rebecca is dew. Okay, what happens when it gets really cold? Anyone lived in Toowoomba?
Yeah,
What happens there to the grass in the morning?
like it's dewy.
Yeah, but what if it's really cold?
gets icy.
Yeah, what's that called?
Frost.
Excellent. Can you see frost here? Okay, we'll go stand up there. Hannah. Okay, now what I want you to do is just grab an arrow. Now what turns dew into frost?
Cold.
Excellent, excellent, excellent. And you can come back over here. And which one of the terms?
Freezing.
Okay, so describe to the class what happens to dew.
It goes to cold. Gets icy. Freezes.
So when we take the thermal energy away,
Goes from a liquid to a solid.
yes, okay, back. Now we'll just move. Sophie, you can bring the frost back, and Maggie. How do we get dew? How do we get dew?
Water vapor.
Where's the water vapour?
From the rain. From the cold.
From the air.
Exact water vapour's in the air. So which way is which way is the temperature going to go to turn water vapour into water?
Into the
Excellent, excellent, excellent. And what do we come over here, Hannah, and pick up the term? You think
Condensation.
it will? So explain to the class again how water vapour gets to dew on the ground.
So from the air it goes into the grass, like the water.
And what happens to the temperature?
It cools.
It's cooling, okay? So when we saw here, okay, when that gas cools, okay, condensation, Sophie said, it goes back into the liquid form. That's excellent, okay. Okay, we'll take our seats. Rightio, so what did we learn from doing that role play?
A lot.
Yeah, what sort of thing, Maggie?
Water vapor and stuff.
Yeah, water vapour is... What's water vapour? A solid, liquid or gas?
Liquid. A gas.
It's a gas, it is a gas, yes. And how do we turn it into a liquid?
By freezing it. By heating it.
Cooling
Cooling it.
it, yes. So we heat it up, we can heat water to become a gas, okay? And we take heat away from gas to become a liquid. That's excellent. And then we extended that, didn't we? We took the dew, which was a liquid, to frost by freezing. Okay, and what happened to that? The bonds in that, the bonds on the water particles in that dew, what happened to them?
They become stronger.
They do become stronger. Okay, so you see how it relates to the lesson we did last week?
Yep.
Okay? Okay. Well, I reckon you've done very well. I reckon you've done very well.